Hi guys. We're continuing today with two more examples, one per video. And today I'm going to change the A into a negative number instead of a positive number. So that'll be the new concept for today, but everything else is a repeat of what we were doing in yesterday's videos. I posted another flowchart, so if you need to print out the flowchart for your notes, you can. And let's get started. So my first example for today, y equals negative x squared plus 2x minus 1. The first thing we should do is identify our a, b, and c. So in this problem, my a is negative 1. It's that negative symbol right in front of the x squared, and that's the new thing today. My b is 2, and my c is negative 1. Now that I've identified my a, b, and c, I can answer my first two questions. Does it open up or down? And does it have a min or max? In this problem, since my a is negative 1, now we're going to say that my parabola opens down. So it's going to be an upside down U shape, not a right side up U shape. And anytime a parabola opens down, it has a highest point or a maximum. So the top of the U is the maximum point. So down and max. All right. That's kind of the only new thing until we get to the graph. So I'm going to keep going as we did yesterday and in our live class today. So next we're going to find our axis of symmetry. And the formula for that is negative b over 2a. So that's negative 2 over 2 times negative 1. And then we simplify. This will turn into negative 2 divided by negative 2, which is positive 1. Now don't forget, your axis of symmetry is an equation. You have to have the x equals part in there. X equals positive 1. After you have found your axis of symmetry, you're going to plug it in to the original equation, the original problem, and you'll do that to find your vertex. Now, I have found that we make a mistake when there's a negative sign in front of the x squared. So to try to help us out and try to help us not make that mistake, I am going to make this a negative 1 in front of the x squared instead of just the negative sign. And that should help us when finding the vertex to not make an error. Oh, that doesn't want to go away. Okay, so let's go ahead and plug in. So again, notice that I did not just put a negative sign, I made it a negative 1. That's this part right here. And then for the x squared, I plugged in this one. So 1 squared. Now we're not squaring the negative sign, we're squaring the 1 from the axis of symmetry. Then we did 2 times 1, 2 times x, and then the minus 1. According to our order of operations, if we're going to do this by hand, we need to do our squaring first and our multiplying second. So first, I'm going to do the 1 squared right here. And then second, I'm going to do the negative 1 times the 1. So make sure you're doing that in the correct order, especially if you're doing it by hand. Okay, so this is going to be negative 1 plus 2 minus 1. Negative 1 plus 2 minus 1. And that turns into 0. So my y-coordinate, and I didn't write it down on the PowerPoint, but I'll write it right here. My y-coordinate is 0, and my x-coordinate I get from my axis of symmetry is the 1. So my vertex for this problem is 1, 0. Okay, next we're going to state the y-intercept, and then we'll graph. My y-intercept is my c value, which I stated earlier was negative 1. So my y-intercept is 0, negative 1. All of this can be found without graphing. Now though, now I do want to graph. So I have my special ordered pairs, 1, 1a, 2, 4a, 3, 9a. And in this problem, it will be important to multiply your y-coordinate by my letter a, because my letter a is a negative number. Okay, so when I multiply the y-coordinate by that negative 1, what will happen is it'll change the y value to a negative number. That's really great because that's going to remind us that my parabola opens down. So by remembering to multiply your y-coordinate by the letter A, you will also remember that your parabola is opening down. Now I put a couple stuff on the graph already. I put my axis of symmetry at x equals 1. That's my vertical line. And then I put my vertex at 1, 0. That's this dot right here. So now I'm going to use my first special ordered pair. And my first special ordered pair says start on the vertex and go over 1 and down 1 since it's negative. And then just don't forget to go also to the left and down 1. For my second special ordered pair, it changes to 2, -4. Okay, so that's telling me go right 2, but we need to go down 4. And then don't forget, you're always starting back on your vertex. Right 2, down 4. And I think we have just enough space to fit that last special ordered pair, which has us going right 3 and down 9. And then we connect. Okay. So notice again, my special ordered pairs changed in this problem because my A was -1. And I do want you to get into the habit of writing these down. Okay, so get into the habit of writing down your new special ordered pairs. All right, after we're done graphing, we have to answer one more question, which is what are the x-intercepts? This is a scenario that we haven't done yet. This is a scenario where there's only one x-intercept because the vertex was actually on the x-axis. And so since the vertex was on the x-axis, my x-intercept is actually the same as my vertex was. So anytime that your vertex is on the x-axis, that would mean it has a 0 for the y-coordinate, then your vertex is also your x-intercept. And in this scenario, there's only one x-intercept, not two. This concludes our first video.